Okay. So the content of today's session is to discuss Lab 2. You can ask any question you have in Lab 2. And then I'm not going to keep you for a long time. I'm going to show you what Lab 3 is about, discuss quickly the theory, and take my time discussing the data analysis and the experimental procedure, and leave you. So hopefully I can do all that in 40 minutes. I just heard that you guys are overwhelmed for this week for quizzes and tests. So no need for us to sit forever to finish up Lab 3. And also I would like to tell you that Lab 2 is one of the longest and most difficult labs you will have, which means once you're done, other labs are going to be so easy. So if you guys frustrated and tired already, don't worry about what's coming up. All right? Yalla, ask me. Lab 2. Go ahead. Somebody was talking to me a few minutes ago. You guys can hear me? Hello?
Yes, doctor, we can hear you.
Okay, anyone has a question about Lab 2?
I asked you a question on WhatsApp about the significant figure and adding the capacitance in part B.
Okay, in part B, yes, this one.
Okay, so basically, Anna, I chose results too. So I had a C1 and C2 and nanofarad.
Yeah.
But I give the value.
Yeah, give me your different value.
Okay, so I had C1 468.6 nanofarad. C2 979.4 nanofarad. C3 it was 1.87 microfarad. Okay. So I did not know how to add them and see in parallel the three of them. I did not know how to add them لأنه significant figures وهيك. I needed to transform them into the same unit. So I did that. I transformed them into microfarad, all of them.
So this would be, correct me if I'm wrong,
0.468.
Okay, micro, which means the dime is something 86, which means I have 4 decimals for this one, 4 decimals for this one, and 2 decimals for this one. So my final answer should be 2 decimals if I'm adding. Right?
Okay, Basak. Okay, but I just wanted to make sure. Okay, dear.
So again, Jean was asking me about how to round when we have different units. I remember I told him, convert everything to the same unit to be able to count the number of decimals, because it's tricky to count the number of decimals. Also, if you have different powers of 10, 10 to the 2, 10 to the 3, make sure that your values have the same power of 10 before discussing the number of decimals. Okay? All right, more questions related to Lab 2.
I needed to ask about the literature values. From where are we supposed to get them? No, I searched on the internet and I don't have an accurate answer.
Yes. So let me, by the way, I should have written an announcement about this because many students are asking about this, and it's not fair to make you anxious. So let me try to explain one more time. This question is not graded, and it's a bonus question in a way. And this question has an open answer question, so there's no one answer to it, which means, and the reason is plastic is not known. You know, any material can be called plastic. Plastic is not a specific way to call a dielectric. Now what you can do is the following. You can compare your K, the K that you have found, with anything found online, and maybe tell more about what type of plastic we have. Or maybe you can find a range of values online and see if your value falls within this range, you know, and so on and so forth. So it's an open discussion. Whatever you find, you can use it under your discussion. So I'm not expecting you to give me one answer or to find one value. Whatever you can find, try to discuss how your answer fits in with what you can find online, you know? Do you think it's possible to be done, George?
Yeah, it's possible. It's Sherbel.
Oh, Sherbel, yes. Try this, okay?
Okay.
And
okay.
Again,
I found an answer, but in every website you find another answer.
Yeah, this
plastic,
is disturbing.
as you said, plastic is diverse.
Exactly. It's not a way to, it's a general description. And we did that on purpose because we want to open a discussion part, if you want, Sherbel, since you're saying that in every website you have a different answer, you can say according to this reference and name the reference, and then you do your own discussion. Okay, so basically we don't care about your answer. We actually care about how you conduct your discussion.
Doctor?
Yes.
When I submitted, I'm just compared. I saw my value came around, my experimental value around 1.6. So I went online. I saw something similar to 1.6, like close. I found like polyethylene. First, I took the polyethylene value and just said it's polyethylene.
Yeah. Okay. Same with Ryan. Okay. You don't have to do, as long as you can write something about it, but be reasonable. It's not like you find a known solution and you say, this is what I found. It has to be something that looks like plastic in a way, All right. By the way, for the students who did not know that we extended the deadline because I did not do it public on Blackboard, the deadline has been extended by a few hours. If you guys would like to unsubmit and submit again, you can upload as many attempts as you like, okay? It will be nice though if you write me a note to explain the difference between the attempts, because now talking about lab 1 myself, I want to give you feedback and I want to ask about your feedback. For lab number 1, not your class, the other section, many students uploaded many attempts and the attempts were similar. Personally, I would like to check each and every attempt and grade each and every attempt. Actually, I have to do that through Blackboard, and Blackboard will eventually keep the highest grade, which is good for you anyway. Which means if you submitted the attempt twice by mistake or just to make sure that you did submit your work, just let me know, because I'm going through the lab report twice to make sure nothing is extra, okay? This is 1. 2, not a lot of students, but like 20% of the students are having their documents modified by Blackboard, like the pictures are changing, not everything is visible due to the fact that you're uploading your work as a document and not as a PDF document. So if you can convert your file to PDF first and then upload, I think it will be better for you. 3, many students are uploading the lab report with image 1, image 2. So I'm receiving around 3 files. Make sure, and this is very important, to upload only 1 file. Yes, you can crop your pictures well and insert in the document. This will not affect your grade definitely, because the way you present your work will not affect your grade. But I want us by the end of the 4th lab to have a nice looking lab report, and you're not far from a nice looking lab report. The best way for you is to have one document, nicely done, remove the manual part, keep the lab report part, have a title, your name, the date, make sure it's a PDF file for you. For personally, it doesn't matter, but for you, for nothing to be modified. And the pictures are well inserted and they're not rotated, for it to be a reasonable lab report. And hopefully we can do the same for the midterm later on. Anything to add concerning lab 1? And you can at any moment agree or disagree with the grade. I'm ready to discuss it with you. Remember, that's an assignment, like a daily homework. It's not a midterm. So we do it, we assess you to be able, for you to learn and for us to know how to provide you with the respective material. So it's not like it's written on stone. So we can discuss, you can agree or disagree with the grade, and I can prove you're right or wrong, okay? Yes. Anything about lab 1?
Yeah, I did not notice that if there is any thing converted from Blackboard since it's blocked for lab 1. So we will have any grade deduction for that?
Say it again, Joe.
For lab 1, I did not notice. I did not check if something from Word to Blackboard converted or any equation was not seen. Will you get any grade deduction for lab 1?
Listen, no deduction will happen for the appearance, how your lab report would appear. I was saying that some students, when they send me their lab report, some pictures were not shown, you know, and some pictures they had for example, the electric field lines, but not the potential lines. They basically disappeared. So if you convert your document to PDF first, then upload it, nothing will change on it. So always do this by habit. Okay, but no deduction will happen, definitely. But if I cannot see your picture, I would think maybe that you did not include it in your lab report. Did I answer your question, Joe? I'm not sure.
Yeah, but I was thinking about the equations, because sometimes they show question mark in
yes, if you convert to PDF, whatever you see on your screen will be the same. It will be an image, like nothing will modify. Okay. Yes, I think so. So, and I'm not done correcting, by the way. I still have 9 lab reports from your class, but I did finish the correction for all other classes. So if you did not receive a grade, do not panic. It's going to happen today, I hope so. All right, is it over for lab number 1? Now lab number 2, do you have more extra questions? Yes.
Will you be sending us our corrected lab reports?
Actually,
or just the grade?
Okay, what you can see on Blackboard is your grade and a lot of comments. Read the comments, okay? There's no corrected answer, like corrected version, because a lot of answers could be good answers. But I would be writing comments about what I agree with and what I don't agree with. Okay, yes, Juliana, I did not correct your lab report yet. This is what I remember, because I remember some names. But you will have it soon, okay? And if you did not ask me the question you want to ask today, you can still ask any question you want later on via email. Any question related to lab?
Mine is corrected because I can see a grade.
You can see a grade, but you cannot see comments. Okay, let me check. I'm still opening your class. Let me see, Juliana. Okay. Maybe you can see the average of the class. Okay, so Juliana is here, and yes, there is a grade for you. Let me open the attempt and let me see why you cannot see the comments. So this is what I have on my screen. Like those pink words, do you see them? Those.
Oh yeah, I see them now, yes.
Okay, so maybe it needs time to open. Okay? So
okay,
these are the comments I was talking about. Yeah, and since, by the way, Juliana, I just noticed something. Since you guys, let me open something to hide the grades. I know it's not fair to keep the grades open. And let me put the chat on because some students are typing. So again, since lab 1 and 2 are basically, I don't know, tough in a way, I suppose if your grade is not if you're not very happy with your grade, maybe you will be expecting better grades starting lab number 3. I don't know, because now lab number 3 and up will be a little bit easier. I don't know. So Carmen is asking about significant figures. For me, it looks good. The decimal inch, I should add a 0. Yes, you have to add a 0. All right. Okay, so what else?
Doctor?
Yes.
In part A, بتفرق إذا we plot C with wires versus 1/D or C without wires versus 1/D.
Of course, C with wires is C of nothing. It's an illusion. It's virtual. Because you want to know the capacitance of your own capacitor. If you add the wires.
We should plot without wires.
Yeah, maybe this is one of the mistakes you did. I'm saying one of the mistakes because I know maybe you have many mistakes.
Yes, most probably I have many.
So now you just gave a hint. Yeah.
That's one more thing. If a question.
Say it.
Can you tell what the dielectric material inside the cable is?
Yes.
Okay, I found K1 and I found K2. I have to get something to compare them to من the internet. إنه كمان إنه ما في شيء إنه لازم to research.
Yes, check online. Check RG58 coaxial cable. What's inside? Try to check whatever K you found, it's close to what. But be careful, it has to be something that we could put in tables. It's not like salt and water, for example. It has to be something reasonable that we put in tables. So what you can do is you can search for different Ks and check which one is the closest to whatever you found, and check the RG58 coaxial cable and try to find something that is close enough for you to include in your discussion, okay?
Okay, thank you.
All right, by the way, I'm very happy with this discussion. Look at you. You're doing a lot of research.
Doctor, I have
Yes,
sorry.
Maria, say it.
Yes, I have a question also in this part. When we're gonna find the capacitance without adapter of cable 1 and cable 2,
yes.
we do تبع capacitance with adapter minus the capacitance of the wires, ولا بعمل cable 1 plus cable 2?
No, it's very simple. You take this one, capacitance with adapter, and you minus this answer.
يعني الكيبل 1 plus cable 2 باخد تبع الكاباسيتنس with adapter minus the wires.
Yes, that's it.
Okay.
Yes.
Thank you.
Okay, shall we move to lab 3?
Doctor, I just have a fast question.
Yes, Anthony, go ahead.
In the percent error, if we do like 1.5 divided by 2, our final answer, should it have the same sig figs as 1.5 or as 2?
Is 2,
or it doesn't matter?
By the way, divided by 2, what is 2? Is it a measurement?
Yes, it's like our actual theoretical value.
Why is your theoretical value one significant figure only? It's weird.
I was just giving like a random example.
Yes, if this is your measured value, but it's less likely to happen because usually my theoretical value usually is more than one significant figure. But if this is the case, yes, you round your final answer to one significant figure.
So if it's division, I see which has the least sig figs and I put that as the answer.
That's true.
Okay, thank you.
All right. So in lab number 3, again, if you have any question related to lab number 2, you can definitely still ask about it. Sherbil, K1, K2, maybe they will be 2 different materials. Okay, comments. I'm sorry, I'm back to the chats, but I just noticed that a lot of chats were not visible by me. The sources of errors. The best way to discuss the sources of errors is to watch the video of the experiment and observe the equipment used and the procedure done. And ask yourself the question, what makes my system and my experiment not to be ideal? Usually in the ideal case, you have vacuum between the plates. Is it the same in the experiment? Usually in the ideal case, we do this, this, and that. Is it the same in the experiment? While we've been doing the experiment in front of the camera, did you notice anything that is not very stable? Or any procedure that we took that is not very precise, like measuring the radius? How precise is that? Try to discuss at least 3 sources of errors because we can easily name 10 or 5. Okay, try to write down the major 3. Okay, all right, I'm sure I did not answer everyone and every single question. It's okay, since you can still ask online if you need anything. I just don't want to keep you forever. Now, resistance and resistivity, this lab is extremely quick and easy. You just need to know Ohm's law. Can you quickly tell me what Ohm's law is? Anyone? Yes, somebody wrote U minus Ri. You meant U equals Ri. How about we write it as delta V, being the potential difference between 2 points, is equal to Ri, where R is the equivalent resistance between those 2 points, and I is the current going through the wire between these 2 points, okay? So I know that maybe you did not start in the course doing potential difference, maybe you're still doing potential, and maybe you did not move to circuits yet, but you're gonna do it soon, which means this experiment is gonna be a warm-up for you, or like a review session for you. I'm gonna show you the circuit in a moment, but now for the theoretical background, you need to remember that in series, the resistance, you add them up. In parallel, you add the inverse of the resistances. By the way, I hate to write it 1 over R. I'd rather write it R to the -1 because it's so much faster on a calculator to click to the -1. Is Michelle with us? Or Michelle is not in this group? Michelle. By the way, Blackboard does not let me to scroll. Like I have to do it by hand. Yeah, Michelle is not here. Okay. She is in a different section. I'm sorry for the interruption. So, and in this lab, they actually discussed the difference between ohmic and non-ohmic devices. Can you tell a little bit, by definition, what an ohmic device is and what is a non-ohmic device?
The non-ohmic device doesn't follow Ohm's law. So when you change the voltage, the R is not constant.
Okay, how can you prove if a device is ohmic? What do?
You can change the voltage and then record the current and then test if the Ohm's law still applies.
Okay, okay, like you have I, you calculate R, but you can always calculate R. I don't see why delta V equals Ri will not be applicable. Knowing R, you mean?
Yes, not only knowing R, إذا بيعملوا linear regression curve.
All right, this makes sense to me. So you plot delta V versus I, and you observe your relationship. It's supposed to be linear. And if it's not linear, so this is non-ohmic. Or maybe if you calculate R following delta V equals Ri, if R is not a constant, because the equation, you can apply it anytime, anywhere, but R equals a constant is what you really care about. So this R, if R equals a constant, it means it is ohmic. Okay, so Jana just mentioned, yes, so Anthony and Cherbel, they're talking about the plot. So we have 2 ways to tell if a device is ohmic or not. Check the plot, linear or not. Check R for different coordinates, constant or not. And here they actually discussed the R for a metal rod. So the R is rho L over A. Rho is the resistivity of the material. You can be playing around with copper or silver or carbon, I don't know. L is the length of the wire, A is the cross-sectional area. But I suppose this section will not be in the lab report, so just keep it for the moment. Now procedure, let me explain the procedure directly through the lab report. So this is the lab report section. By the way, somebody asked me a few minutes ago on the chat, on the WhatsApp chat, about the manual. I uploaded in the manual folder a PDF version and a doc version of the manual, because I know that you need to copy paste and create your own lab report. I'm not being able to do lab 1 alone, lab 2 alone, and lab 3 alone. I tried twice. For some reason, the files are corrupted and not being able to upload on Blackboard. And to be honest, it's extra work for me. Since you have the manual and you can download it once, you take anything you want from it. Why do the work twice? But I also noticed that the doc file is not as pretty as the PDF file. Some tables has been moved. I don't know why though. I did this document, but I sent it to LAU and LAU sent it back to me. So why the modifications, I don't know. If you believe something looks weird on the manual, the PDF, let the PDF be your reference, and the document is only to use it as a template and to play around with the tables that you have. So now what do you have here? You have R equals 10 ohms. I will show you the experiment in a moment. You have a generator with a variable voltage. You vary the voltage and you measure the currents, and the software will give you a straight line. I'm gonna give you all the coordinates on the straight line for R equals 10. And for R equals 33, which is a different circuit, I will give you all the coordinates on the straight line, okay? You are supposed to know the errors alone. I can give you a hint. The errors, this measurement given to you, you can actually see it on the video, is a digital measurement. So you can easily tell the error from a digital measurement, I suppose, knowing the unit and the error easily. Now, question number 1, calculate the experimental value of the resistance for each set of values. So don't do linear regression. They want you to take A, to take V, like each I and V, and find R. For each I and V, and find R again. And I suppose that all these R's will be very close to 10. Then they want you to find the average, and this is not difficult, I suppose, and the root mean square, error on the average. So you do all the average, all the values, 5 values, find the average, easy. Root mean square. It's time for you to make sure you know how to do it. Like if you did not learn how to do it yet, it's time. And this is the only data analysis trick you have in this lab report. So watch the video again, how to use your calculator. If your calculator is different, yes.
Doctor, for the first question, can I just choose the equation R equal to V times I?
Yes, this is what you will be doing because you are given I and V, find R, that's it. No, and Joe,
because I heard linear regression.
Joe, I beg you, just say Jesse, stop calling me doctor. I feel out of space.
Okay.
Yes, so linear regression. No, don't do linear regression. I know you have the line and it would be awesome if you do linear regression. But in this lab, they want to train you to do averages and RMS.
So just use the equation, apply, find the distance for each, then do average.
Yeah, that's it. I know that maybe linear regression is faster and smarter, but here they want you to follow those steps. It's only, the purpose is only to you to practice averages. Okay, so try to follow the questions. So if your calculator is different than the one you can see in the video of RMS, and if you cannot find the video, let me know, I can send you the link again. Learn how to do it on your calculator. It has to be quick and it's very beneficial. Now they want you to compare your final average with the nominal value. So it has to be very close to 10 ohms. If I remember well, it's 9 point something ohms. And then how do you compare? You do the percentage difference, obviously. Comment on the possible sources of errors. Try to list at least 3 sources of errors. And how do you do so? Watch the video of the experiment and try to see what makes your experiment not ideal, you know? And if you're still having difficulties on that level, let me know. Maybe I will find a way to give you some hints. Then you put the resistors in series, like I'm talking about the 10 and the 33. You repeat the experiment, I give you the values, and you're supposed to find R for each set, find R for each set, and do the average and the RMS. So it's a repetition. Compare sources of errors. If you believe the sources of errors are still the same, you can simply say same as above, like as in item 4, or you can add maybe at least 1 extra source because now you have a new procedure, a different experiment, or like a tiny different change. Think about it, it's up to you. Then you will be dealing with non-ohmic devices. You will be given a bulb. Okay. Yes. First of all right, let me show you something. When you plot V versus I or delta V versus I, you get something like that because your generator is giving you variable voltages. Otherwise, you won't be able to plot. And it does it so slowly, like you can see the point moving on the line. Okay, so your generator is a variable generator with a certain frequency. It's most probably a sinusoidal signal with a known amplitude and a known frequency. For the resistance, I've been using a random frequency. For the bulb, which is my non-ohmic device, I will be using 2 types of frequency. One that is below 1 hertz and one that is around 50 hertz. Because the behavior of the bulb is gonna be different for different frequencies, and you will observe that on the graph in the video and on the board looking at the brightness of the bulb. They want you to fill in the table. Definitely, I will have to do this for you. Now for the errors, it's a digital measuring tool, so you will guess the errors easily. Calculate R, you can do the calculations for R. Now, how do you find the error on R? You have to do propagation of error because R is a calculated value. So knowing the error for V, error for R, you deduce the error for R. And it has to be different for each. So because R is different, I suppose. Then what can you conclude from the change of the resistance? You will see a certain change, obviously, because it's a non-ohmic device, and you will say if it's ohmic or not. They want you to sketch the curve. I did the experiment for you, so you will see the curve on the video. So your job is to sketch it, like show the axis, label it V versus I, and show how it looks like. Is it a curve, parabola, straight line? Just sketch the shape, okay? And explain why it's a curve or why it looks like this. This one, I'm still in number 12. So you have to sketch. For number 13, you modify the frequency to 50 Hertz. You explain how the curve will look like, and you explain why it looks as such. I will show you the video in a moment. Question number 14 is not related to the experiment. It's like an extra work for you to do. Like they give you a certain alloy, and they give you the values for current and voltage, and they want you to discuss if it's ohmic or not. So it's a final discussion to wrap up the lab report. So you can see the lab report is super quick. You have 13 questions. You don't have data analysis to do. Basically, it's limited to average, root mean square, compare, and comment. And some related discussion for ohmic, non-ohmic devices. If you don't know and do not understand why the bulb is acting like this, do some reading and watch the video many times. Okay, many times. Do some readings about the bulb, how the bulb functions, why is it ohmic, why isn't it ohmic, and so on and so forth. Now the video, I remember from my first session that the video was 9 minutes long. I always like to see the length of the video before watching any video. I'm not gonna watch it all with you. I simply want to show you the most important stuff. Okay, so let's see.
Hello, I will introduce resistance and resistivity experiment for you. The equipment needed, you would need the RLC.
Okay, so I'm gonna explain what's on the board. You only need this resistance, 10 ohms, this resistance 33, and this bulb. I think there's a close-up of the board. So you can see it here, I think.
It's gonna be used today. Today you only need 2 resistors and the bulb. The first thing you do,
all right, and I'm gonna show you
you go into your desktop.
Okay, let me show you the connections. Okay.
You need to connect the terminal of your output from the Pasco Universal Interface to the SCR board. Connect it first to my first resistor. So this is the first terminal and this is the second terminal of the resistor. You see it?
All right, so what do I have here? I have a very simple circuit, a resistor, a generator, and that's it, with 2 wires. So you don't see any measuring tools because the interface actually sends a known current and actually sends a known voltage and records the current or the resistance on the current, which means it can directly give you V versus I without any measuring tool because it can tell how much it has received and how much it has delivered, you know? So it will give you directly the graph. Maybe you can see it now.
The polarity.
Okay, let me show you the graph.
Do the work for me. You see a linear curve happening. By the way, this is voltage as a function of current again.
By the way, while watching the YouTube videos, make sure you have good resolution because sometimes you need to do some good observation or good readings. So do you see that the measurement is happening slowly, which means my generator is an alternating generator. You can see positive values for V and negative values for V, which is okay because positive value for V would give you positive value for I. So the ratio resistance is gonna be positive always. Same with negative, negative will give you a ratio that is positive. And let me see the next section.
And the output is an alternating output. So you.
By the way, I used the smart tool to take coordinates on this point. As simple as that. For the next circuit, I used the next resistance. Here I'm showing you the series connection.
Both resistors are already in series, right? Because they are already connected through the board. All you have to do is take these 2 terminals to the interface. So do this and that, 2 resistors in series, so you should get a resistor in equivalent resistance equal to the sum of both, which means the slope is gonna be higher. How about I try to record another characteristic, another curve, another graph of the voltage as a function of the current, I should get a straight line as well with a greater slope. You see it?
Do you see the greater slope?
You need to stop recording.
All right, now let me move to the section of the bulb where you connect the bulb.
The terminals of the bulb to my interface. Yes? And
so it's very similar to the first section, but instead of a resistor, I use a bulb. And I'm gonna show you both graphs, like frequency 1 Hertz and frequency 50 Hertz. And then I'm gonna show you the brightness of the bulb, and that's it. And you watch the video later for the specific details.
Try exactly the same thing. But before doing any of that, I'm gonna have a look at the signal generator. The amplitude of the signal.
Okay, I'm gonna make sure the amplitude is not too high because I don't want to burn the lamp. Also, I wanna make sure that the frequency is low because they ask me for a low frequency. And I'm gonna click on record and I get this shape. So is this linear or not? Is this ohmic device or not? What do you think? Anyone? So everyone is typing on the chat that this is not ohmic and this is not linear. All right, so think about it and you know how to sketch this. Just show the shape. It looks like a curve and it's not even a function because for a known x, you have different y's. So it's weird why the bulb actually behave as such. Joe, you mean by yes being a linear function or close to be linear? What do you mean by yes? Okay, so Joe thinks this could be linear, okay? But anyway, Joe, I cannot zoom in unless I take a screenshot. Don't you see a curve in a way? Maybe the behavior is close to a linear behavior. Now, Reem, do you hear Reem screaming outside? This is how she plays. All right, anyway, forget about her, try to ignore her. Let me show you what happens. So this, let me show you, maybe it will not be visible.
I will get this shape.
So this shape is for high frequency, 50 Hertz.
What does this shape say?
Okay, do you see the video? It shows that you get a straight line with low slope, and then in few seconds or few fraction of seconds, you see a slope, a higher slope. So the behavior is linear, but the slope the first few seconds is different than the slope later on. Okay, and I will repeat it.
I have a feeling that this one is taking measurement on this straight line.
And it's still taking measurements, by the way.
Voltage current relationship would show that my device is acting like an ohmic device.
So it's like the bulb acts like an ohmic device sometimes for some frequencies, and for some other frequencies it does not act like an ohmic device. And we know it's not an ohmic device, but we're talking about acting like one or not acting like one. I think the best way to be able to answer this question is to do an observation directly on the board. So let me show you the board because I really believe this has been very important to be able to explain.
So again, this is a good view of your board. I want you please to focus on the bulb. The bulb is switched off. Yes. I will take my signal generator and make sure that the frequency is back to 0.3 Hertz, back to when it gave me this weird shape. I will start recording. I want you to notice that the brightness of the bulb varies. It will go on and off, on and off. Slowly, the frequency is 0.3 Hertz, so it does it 0.3 times per second. Or maybe 3 times every, I don't know how many seconds, you know? It's 1/3. So every 3 seconds, it goes on only one time. So it's a very small frequency. That's why you see it very slowly going on and off. And at the same time, you get this weird shape that you saw on the voltage versus current curve. I will stop recording. I will go back to my signal generator. I will change the frequency to 50 Hertz. And I will start recording again. Notice that the brightness of the bulb is somehow constant. Some would say that it will go on and off so fast frequency 50 hertz, meaning 50 times per second. That cannot be seen in the naked eye. I don't know on the video if you see any fluttering, any variation in the brightness, but using my naked eye, I see no variation in the brightness whatsoever. This could be somehow related or not, it's up to you to think about it, to the fact that the voltage versus current curve looks like a straight line with a constant slope or not.
All right, so try to use the observation on the brightness to explain why the curves are actually changing with different frequencies, and read a bit about the behavior of the bulb or the behavior of the resistance of the bulb so you can answer the questions, okay? So that's it for lab number 3. So I hope it's not gonna be a long lab report, so for you to have at least a mini break between after lab 2. Any questions?
Doctor?
Yes.
At least for the other labs, can we shorten it a bit? When we're doing it alone, we should know 2 or 3 people.
Okay, so what do you need? Extra time?
I don't know, either extra time or shorten it, shorten the reports a bit. Because it's like we're doing it for one individual. Like أنا بعمل لحالي.
Okay, so you think the lab reports are long?
Yeah.
Okay, listen, I can do something. Instead of giving you 1 week, I can give you for each lab report 8 days or 9 days. But then I know it will not be very beneficial, especially that you will have another lab on top. So, but maybe, all right, let me start by giving you 8 to 9 days. This is as a start. 2, you'll give me feedback next time about the length of the lab report. I want to know all lab reports are long or is it only lab 2? So if it's all lab reports are long, so I'm gonna give you extra time and shorten the lab reports. But the lab reports, I believe, are gonna be really short in the coming weeks. So maybe the length will not bother you anymore. And yes, I can give you a longer deadline. Okay, how do you know your deadline? Now, how do you know your deadline? Because maybe it will be difficult for me to let you know. Just when you go to submit here, it tells you what the deadline is. So instead of giving you a deadline that is Monday at 2 p.m., I can say it's Tuesday midnight. So it's like I gave you 1 day and few hours. Do you think it's gonna be a little bit, does it make any difference? Because to be honest, personally, I'm not being able to finish all the corrections in 1 week. So I totally feel you. But I don't want you to drag because this is bad for you anyway. So a structure...
Yeah, we'll check for lab 3 and then we'll see.
Okay, so I'm gonna extend the time for lab 3 and I want you please to speak up next week concerning the length of the lab report. You're Joe, right?
Yes.
Okay, I'm gonna try to ask you next week, but I'm scared I'm gonna forget. So if you can remind me, okay?
Doctor?
All right.
Yes.
Doctor, can you consider not making it individual work?
I tried. It did not work. I tried not for you actually. I tried for myself because I needed a way to correct all these lab reports. Imagine having 70 lab reports every single week for 12 weeks. This is beyond a nightmare because you know the nightmare finishes in one night. This is over 12 weeks. So I tried, but it's not gonna happen because the administration believes it's not good for you. And they do believe that anyway, it's not safe to meet, and meeting on a virtual basis is not gonna happen efficiently. So they don't want to offer you this. So it's not something I decided personally, or not many instructors. It's basically the coordinator and the admin, and I believe it's happening in many schools as well. Hopefully in the coming weeks, things are gonna change a bit because I'm not sure I'm gonna survive this. So, you know, try to divide the work over 2 days and let's see how it's gonna be with the coming labs, and maybe this will be reflected on your midterm, because since you're doing the work alone, like you don't need to study for the midterm anymore, or maybe you don't have gaps for the midterm anymore. So it's gonna show up somewhere, you know?
Okay.
But I totally feel you, Jana. Let's try to do it. Like I insisted initially, but then I asked myself, Jessie, try it and see how it will go. Okay, maybe it's a wrong decision. Let's try it for at least 3 or 4 lab reports. Okay?
Okay.
So Jana, you can ask again the same question next time, just for you to give me feedback about how things are. Any other comments? All right, so if you guys don't have